Here we have a problem on indices. We have to simplify the expression we have here. Okay, in the given expression there are three fractions added. So to get the simplification of this expression, what we have to do is we have to simplify each fraction separately. So we will be getting three different results, and then we have to add all the three results and do further simplification to simplify the given expression. So let's simplify the first fraction. In this fraction, the term a to the power of m minus n can be written as a to the power of m divided by a to the power of n, and in the same way a to the power of m minus p can be written as a to the power of m divided by a to the power of p. That is 1 divided by 1 plus a to the power of m divided by a to the power of n plus a to the power of m minus p can be written as a to the power of m divided by a to the power of p. Okay, now what we can do is we can add these two fractions, but both the fractions do not have the same denominator, so we can do cross multiplication. That is, this numerator a to the power m is going to be multiplied by a to the power of p. A to the power of m times a to the power of p will become a to the power of m plus p, and this numerator a to the power of m is going to be multiplied by a to the power of n. Then we get a to the power of m plus n. Now we have to multiply these two denominators, so a to the power of n plus p. Okay, now I am going to add this fraction to this integer 1. For that, what I have to do is I have to multiply this denominator and this 1. So then I get 1 divided by a to the power of n plus p plus a to the power of m plus p plus a to the power of m plus n divided by a to the power of n plus p. So once this multiplication is done, we can take this a to the power of n plus p as a common denominator. So in the next step, this denominator will come here and multiplied by 1. Then we get a to the power of n plus p by a to the power of n plus p plus a to the power of m plus p plus a to the power of m plus n. When I consider the exponent of the numerator, this is nothing but the alphabets with the negative sign in the given fraction. In the given fraction here, there are only two alphabets, n and p, with negative sign. The same two alphabets we have here in the exponent of numerator after simplification, and also those two alphabets are added. So this is the idea we have to keep it in our mind when we simplify the remaining two fractions. So to get the exponent of the numerator after simplification, what we need to do is we have to add the two exponents with the negative sign in the given fraction. Addition of those two exponents to be taken as exponent of the numerator. Okay, and also we can consider the terms of the denominator. There are three terms added in the denominator, and all the three terms have different exponents. When I consider the exponents here in denominator, it's very clear only the three alphabets m, n and p are circulated. So the addition of m and n we have as exponent in the last term, I mean in the third term here. The addition of n and p is being as exponent in the first term, and the addition of m and p is being as exponent in the middle term. So even when I simplify the remaining two fractions, I'll be getting the same denominator what I have here. So the order of the terms only will be different. So that's not a problem because all the three terms are in addition. So when I simplify the remaining two fractions, I don't have to worry about the denominator. So because whatever denominator I have here, the same can be taken as denominator after simplification for the other two fractions. Only for the numerator we have to keep the idea, that is, we have to consider the alphabets with the negative sign in the given fraction. So we have to take those two alphabets. The addition of those two alphabets should be taken as the exponent of a, and that should be taken as numerator here. So in our problem, in the given fraction, I mean in the first fraction, there are two alphabets with negative sign. They are n and p. So I have added those n and p. That is taken as the exponent for a. Then a to the power of n plus p is taken as numerator here. So in the same way, without doing all the calculation we have done here, we can get the simplification of the second fraction and third fraction. Okay, let's get the simplification of the second fraction. Here the second fraction is 1 divided by 1 plus a to the power of n minus m plus a to the power of n minus p. Okay, when I simplify this second fraction, I'll be getting the same denominator what I got when I simplified the first fraction. So after simplification, the denominator of the second fraction will be a to the power of n plus p plus a to the power of m plus p plus a to the power of m plus n. Okay, so to get the numerator, already we have created an idea when we simplify the first fraction. That is, we have to take the alphabets in the given fraction with the negative sign. Here in the second fraction, there are two alphabets with the negative sign, negative m and negative p. So let's take the alphabets m and p. And we have to add those two alphabets m and p, and should be taken as exponent for a. So then a to the power of m positive p should be taken as numerator. So this is the simplification of the second fraction. So based on the idea we have created when we simplified the first fraction. Okay, now let's simplify the third fraction. Here the third fraction is 1 divided by 1 plus a to the power of p minus m plus a to the power of p minus n. Okay, after simplification, we'll be getting the same denominator. So what we got after the simplification of the first fraction, that is a to the power of n plus p plus a to the power of m plus p plus a to the power of m plus n. And to get the numerator, what we need to do is we have to add the alphabets with the negative sign in the given fraction. Here the two alphabets m and n are having negative sign in the given fraction. Okay, so now we need to add those two alphabets m and n. That should be taken as exponent for a. Then a to the power of m plus n will be the numerator. So this is the simplification of the third fraction. Okay, now we can move to the original question, and we have to substitute the simplification of the first fraction, second fraction and third fraction, and do further simplification. Okay, let's move to the original question. Here I have substituted the results of all the three fractions after simplification. Now what I have to do is I have to add all these three results to simplify further, and all the three fractions have the same denominator. So now what I can do is I can take the denominator once, that is a to the power of n plus p plus a to the power of m plus p plus a to the power of m plus n. So I have taken the denominator once, that is in common. Now I have to add the three numerators. So this is a regular process in addition of fractions with same denominator. So a to the power of n plus p, a to the power of m plus p plus a to the power of m plus n. Now in this fraction, both numerator and denominator are same, so we can cancel them. So the result is going to be 1. So the simplification of the given expression is equal to 1.